Okay, so have you got the solution to this problem? Yes. So can you tell me what is the solution to this problem?
Sixty twenty, sir. Z max 1100.
So mm, x1 is equal to 60, x2 is equal to 20, and Z max is equal to 1100. Okay, so that is the solution. Am I right?
Yes, sir.
Yes, sir.
Okay, so you got the solution. Now you have found out the solution by using extreme point enumeration method. Now there is another way of doing it. What is that? Yesterday I have told you.
Isoprofit line, isoprofit line.
If at all it is maximization problem, then isoprofit line you have to draw. If it is minimization problem, isocost line you have to draw. Now how to draw that? Now for this particular problem, you have to convert the objective function equation into equation of line. What is the equation of line? Equation of line?
Y is equal to mx plus c.
Y is equals to mx plus c.
Yes, correct. Okay. So what is our objective function?
Z is equal to 15x1 plus 10x2.
15x1 plus 10x2 is objective function. Can you convert this into equation of line? Yes. X2 is our y coordinate. So x2 is equal to z divided by 10 minus 15 divided by 10 x1. Am I right?
Yes, sir.
Okay. So this is y is equal to mx plus c. What is m? M is slope.
M is slope, sir.
M is slope of a line. So here m is equal to, this is z by 10 is constant, minus 15 by 10 x1 is your mx. Okay. So what is m here? In this case, m is equal to minus 15 by 10. That is nothing but minus 3 by 2. Is it okay?
Okay, sir.
Okay. Now, can you draw a line having slope minus 3 by 2 on this particular graph paper? On this particular graph paper?
Yes, sir.
Okay. So
Yes,
you have
sir.
to draw a line which is having slope minus 3 by 2. Minus 3 by 2 means sloping towards right. Means from top to bottom, it will go from towards right. Okay. That means in this direction. Let me draw here. In this direction. This is minus slope. Okay. So
Yes, sir. Correct.
what is 3? 3 is on x1 axis, no? Or on x2? 3 is on
Sir, Y, X2.
y, yes.
Y.
So suppose this is 30, then this will become 3. This point is of 30 and this is 20. So you can draw a line in this manner. Is it having slope 3 by 2? Yes or no?
Yes.
Yes, sir.
Yes. Now what you have to do is, you have to take a parallel rule and move this parallel rule parallel to this particular line in this manner. Okay. So you go towards, from 0 towards infinity or outside of this in this manner. If you go on drawing parallel lines or using this your parallel rule and move that parallel rule parallel to the line which we have drawn having slope minus 3 by 2, then this line will leave the feasible region at the single point, and that single point is B. Am I right? That single point is B here. Am I right or wrong?
Yes, sir.
Okay. So if you go on drawing the parallel lines or moving the parallel rule from your line or from 0 parallel to the this minus 3/2 slope line and move away from 0, 0, it will leave the feasible region at one point, and that point is nothing but the optimum point. So here B is the optimum point. Are you getting me? So you need not have to check all the extreme points and find out the Z value. So here B will be directly the solution. That means your x1 is 60, x2 is 20, and put those values into your objective function, you will get Z max. Is it okay?
Okay, sir.
Okay. So you solve it by extreme point, solve it by isopropyl line as well. Draw isopropyl line and you check that whether it is matching with B point or anything else. Definitely you will get the point B only. Is it okay? Okay. So this is another way of solving it. Now yesterday we have solved some more problems. Which one? This problem we have solved. Okay. Yes or no? The first one which you have already taken.
Yes, sir.
Yes, sir.
This problem. Okay. So can you draw isopropyl line? Now as it is maximization problem, you can draw isopropyl line for this. Draw isopropyl line for this particular on whatever graph you already completed, and then move it by parallel rule and check that whether whatever extreme point enumeration solution is there is same solution you are getting or not. Check it. Like a check for this problem. Now for this problem, tell me what is M? Anybody?
Minus 8/7.
So M is equal to minus 8/7. Now draw a line having slope minus 8/7 and then move it parallelly away from 0. It will leave the region at point. It will leave the feasible region at point Q18,8. So that you will get this as your optimal solution. Is it okay? So this is the solution. You have to draw the line so that you can get it. बरोबर है?
Oh, sir.
Okay, now we have solved one more problem, no?
Yes, sir.
This one. This one also you have got. Now solve this by which method?
Iso cost line.
Iso cost line, correct, because it is minimization problem. Okay, now draw the line having slope. How much is the slope of that line if you want to draw? सगळ्यांच्या लक्षात येते ना? All others?
Yes, sir.
Roll number 75. Okay, roll number 12 is there?
Yes, sir.
Okay, are you getting this?
Yes, sir. Yes, sir.
Okay, roll number 5.
Yes, sir.
Roll number 19.
Yes, sir.
Okay, roll number 82.
Yes, sir.
Okay, so all of you are with me. If any doubt is there, you just ask me so that it can be completed at that time. Now tell me what is the slope of this? For this solution,
Minus 2 by 5.
-5.
Minus 5 by 3.
Minus 5 by 3.
m is equal to minus 5 by 3. Okay, now draw a line having slope minus 5 by 3. काढले का? -5 by 3 म्हणजे 3 इथले पार्ट घेतले, 3 पार्ट म्हणजे 90, समजा 120 घेतले, तर इथलं 160 घ्यायला लागेल, किंवा काय इकडे काढली तरी चालते. 0 च्या जवळ लाईन. इथं आयसोकॉस्ट लाईन काढलेली दिसते का तुम्हाला? डॉटेडनी दाखवले बघा. This one is isocost line.
Yes, sir.
This dotted line is isocost line. Okay. So
Okay, sir.
if suppose it is drawn, now you have to take this isocost line into feasible region first. Parallel rule ने काय करायचं? Feasible region मध्ये जायचं आहे. Drawing a parallel line to this particular slope line, and then take that line and that parallel rule towards zero, and see that at which point the this line leaves the feasible region. That point is nothing but your what? Optimal point. Now here if you draw some minus 5 by 3 line, then draw parallel lines to that and go to the feasible region, then go again towards 0 line, and you can check that it is leaving the feasible region at point P, which is having coordinates as 0, 144. Am I right? So your solution is this again. X1 is equal to 0, X2 is equal to 140, and Z min is equal to 3, 4, 5, 6. Is it okay?
Yes, sir. Sir, what is the significance of isocost line? Why does it coincide with points?
Because you are interested in ultimately confirming your objective. Okay. In that objective, there is a contribution of your decision variables, and the same decision variables are there in the constraints. So all those constraints get fulfilled. Now, if you draw a line having slope of that objective line, then objective function line, then the objective function line, so for the objective function line in the feasible region, you take any point on that line, it will satisfy all the constraints. But when you move that particular line in one direction, so that it will leave the feasible region. As soon as it leaves the feasible region, whatever point is there, that point will give you the topmost point or the optimal point where we are getting the unique solution, which is the optimal solution. So that line, so for graph is concerned, because you are drawing 2-3 lines of constraints, you are using those constraints to confining the feasible region. Now, in order to get the optimal solution, you have to focus on what is your objective. Otherwise, if you choose any point from the feasible region, that will be your feasible solution, no doubt about it. But if you focus on the objective function, then you will get the optimal solution with respect to that objective function only. Now, if at all you You keep the same constraints and change your objective function, your also profit line or also cost line will change and your solution may change. Are you getting me?
Yes, sir.
So it is correlated with objectives and constraints. That's all.
Yes, yes, sir.
Okay, that is the significance. Okay, now I think you got this. Now I will give you one more problem. You just try to solve this. Okay? Okay, take down minus x1 plus 2x2. x1 plus 2x2. Or rather, what is the objective function? Hmm. Maximize z is equal to 2x1 plus x2. Okay, subject to linear constraints of x1 plus 2x2 less than or equal to 10. Then x1 plus x2 less than or equal to 6. Then x1 minus x2 less than or equal to 1. And then x1, x2 both greater than or equal to 0. So solve this problem by graphical method.
सर सर डाऊट होतं ते स्लोप कोणत्या लाईनचं घ्यायचं होतं
काय
स्लोप कोणत्या लाईनचं घ्यायचं खायचं प्रॉफिट लाईन काढलं
ऑब्जेक्टिव्ह फंक्शन लाईन ऑब्जेक्टिव्ह फंक्शन
ओके सर
एक्स्ट्रीम पॉईंट एन्युमरेशन सोडवा ना किंवा यांनी सोडवलं काय हरकत नाही मी आपलं जस्ट सांगतो बट यू टेक एकच लाईन ऑब्जेक्टिव्ह फंक्शनचा स्लोप घ्यायचा ऑब्जेक्टिव्ह फंक्शन इक्वेशन
Sir, 3.5, 2.5.
3.5 and 2.5 m किती येतोय
Sir, नाही एक्स्ट्रीम पॉइंट इन्युमरेशन नी सोडवलं.
चालेल किती येतं उत्तर
9.5.
नाही काय तर तुझं थोडं स्केल कमी घेतला का छोटा काढला
सर
का
1 घेतली. नाही सर 1 घेतली आहे.
हा बघ जरा जवळ आहे तुझं उत्तर पण इंटिजर व्हॅल्यू मध्ये येते म्हणून सांगतो
नाही सर 9.5 येते.
सगळ्यांचं तेच येते प्रॉब्लेम बघू
हो सर 3 येतं 9.5 2 आणि 12
अरे थांबा जरा माझं चुकलं इथं ऍक्च्युली एक कन्स्टंट मिस झाला तरी म्हटलं काय तर चुकतंय यू रीड्रॉ इट काय नाही फक्त तुम्हाला एक लाईन जास्त करायला लागेल देर इज वन मोर लाईन देर इज वन मोर कन्स्टंट रादर x1 minus 2x2 is less than or equal to 1 and this is greater than this is less than or equal to 2 x1 minus x2 less than or equal to 2 x1 minus 2x2 less than or equal to 1 and now x1 x2 greater than or equal to 0 solve this problem एक लाईन खोडावी लागेल तुम्हाला x1 minus x2 less than or equal to 1 वाली आणि परत ड्रॉ करायला लागेल करा बरं आता see whether this is the solution you are getting for this particular problem or not. अशी लाईन येते. ऍक्च्युअली x2 ऍक्सिस वर निगेटिव्ह पॉइंट्स येतात की ते गृहीत धरून तुम्हाला लाईन ड्रॉ करायची आहे. बट ऍज वी आर इंटरेस्टेड इन x1 x2 greater than or equal to 0, your feasible region is in quadrant 1. So that much portion is shown here. सगळ्यांचं असं येते का?
हो सर.
Okay. Now you consider extreme points, which is O, A, then B, C, D, and E. Or you can draw isoprofit line. It is mean maximization, no? O. So you can draw a isoprofit line, then take it away from 0, 0. It will leave the feasible region. I think at point, just check it whether at D or C. I think at D. And 2, 4 will be your answer. And Z max will be, I think, 10. Is it 10? 2, 2, 2, 2, 2. No, 4, 2. Not 10.
8, sir.
8 sir.
No, then C will be the answer. Just check it.
Yes, sir. C.
C, no? C is correct.
We get 10.
मी काही तर लाईन काढलेली नाही आहे किंवा एक्स्ट्रीम पॉइंटला पण चेक केलं नाही. तुम्ही बघा डी ला किती येते? 8 येते. सी ला 10 येते म्हणजे सी, बिकॉज झेड मॅक्स वी आर इंटरेस्टेड इन मॅक्सिमम. तुम्हाला सगळीकडे चेक करावं लागेल. x1 x2 लाईन वरचे पण पॉइंट घेऊ शकता किंवा जर तुम्ही आयसोप्रॉफिट लाईन काढून केलं तरी चालेल. कुठली मेथड तुम्हाला कम्फर्टेबल आहे ती तुम्ही सोडवा. जर एक्झाम मध्ये विचारलं असेल की सॉल्व इट बाय ग्राफिकल मेथड, you can use any method, extreme point enumeration or isoprofit or isocost line. ठीक आहे, पण ग्राफ तुम्हाला काढावा लागेल. आणि जर एक्झाम मध्ये असं विचारलं असेल सॉल्व दिस बाय युजिंग ग्राफिकल मेथड अँड आयसोप्रॉफिट लाईन, देन डोंट कन्सिडर एक्स्ट्रीम पॉइंट, डायरेक्टली गो टू आयसोप्रॉफिट. जर तसं काही मेन्शन केलं नसेल तर यू कॅन यूज एनी वन. इज इट ओके?
ओके सर.
यू आर कम्फर्टेबल.
ग्राफ स्केलने काढावं लागेल का?
हो, स्केल नाही. त्याशिवाय कसं उत्तर येणार बरोबर?
नाही सर, दुसऱ्या मेथडने केलं तर त्याला नाही लागणार ना.
कुठल्या?
एक्स्ट्रीम पॉइंट्स टाकून बघितलं तेव्हा.
पण ते एक्स्ट्रीम पॉइंट तू ग्राफ काढल्याशिवाय कशी येणार आहे तुझ्याकडे?
हा, पण ते ग्राफ स्केलने नाही काढलं तर असं म्हणतोय.
अरे ग्राफ स्केलने नाही काढलास तर ते एक्स्ट्रीम पॉइंट्स बरोबर येणार आहेत का ग्राफ पेपर? मग ग्राफिकल सोल्युशन कशाला म्हणायचं त्याला?
येस सर.
ग्राफिकल सोल्युशन म्हणजे ग्राफ पेपर पाहिजे आणि तू स्केल ग्राफ काढला पाहिजे. आता मला इथे काढता येत नाही म्हणून मी तुम्हाला डायरेक्ट सोल्युशन देतोय. माझ्याकडे काय ग्राफ वगैरे नाही आहे. करता येईल.
इंटरसेप्ट मेथड नाही येत ना.
इंटरसेप्ट मेथड येतं, नो डाऊट अबाउट इट, बट यू गो फॉर ग्राफिकल मेथड.
ओके सर.
ग्राफिकल म्हणजे ग्राफच काढायचं, म्हणजे पूर्ण फिजिबल रिजन वगैरे डिसाइड होतो. ठीक आहे.
येस सर.
आणि फिजिबल रिजन दाखवायचा. whenever you are solving the problem, show the feasible region, then give the optimal solution, then that will be your final solution. Is it okay?
Okay sir.
Okay, now take down some problems. Okay, and then you solve them by yourself. These are some special cases of graphical method or linear programming problem. Then you try to solve this by yourself, and then you come prepared for along with that for the next lecture. Okay, ठीक है?
Okay sir.
Yes sir.
ठीक है. तो for next lecture, in the sense for next tutorial, which is on Friday at 3:30, what we will do? Friday at 3:30, you have to show me the solution of whatever 4 problems I am giving you for graphical method, and I'll give you 1 or 2 problems of model formulation. Okay, that you have to solve during the tutorial itself. Then scan all these, graphical as well as these, and upload it on Moodle. Is it okay? Then I will check it and give you the assignment mark.
Okay, sir.
And next tutorial onward, I will directly, I will not give you beforehand any problem. I'll directly give you problem at tutorial time only, and you have to solve it there and upload it before your tutorial ends. Is it okay? So that
Yes,
your
sir.
action will be done.
Yes,
Now,
sir.
now we have completed two chapters, or rather three chapters, small topics. One is introduction to OR, second is model formulation, third is graphical solution method. Now there are special cases. You just try to solve them. Then while discussing simplex method, we will again compare with graphical solution, and we will try to understand those special cases as well. Okay. So before that, you just try to complete that. Okay, now I will write those problems here. Okay, take down the first problem. If z is equal to 8x1, rather maximize, this is maximization problem. Z is equal to 8x1 plus 16x2, subject to linear constants of x1 plus x2 is less than or equal to 200, x2 less than or equal to 125, 3x1 plus 6x2 less than or equal to 900. x1, x2 greater than or equal to 0. कितना सगळ्यांनी लिहून हा?
सर लास्ट इक्वेशन सर एकदा. लास्ट इक्वेशन काय होतं? 3x1 plus 6x less than is equal to
3x1 plus 6x2 is less than or equal to 900. मी
900.
लिहिलेलं दिसतं ना? म्हणजे whether screen is visible?
Yes, sir.
Yes, sir.
No, I have written it on screen. Now take another one. Maximize z is equal to 20x1 plus 30x2, 20x1 plus 30x2, subject to linear constants of 2x1 plus x2 less than or equal to 40. Then 4x1 minus x2 less than or equal to 20. Then x1 greater than or equal to 30. x1, x2 greater than or equal to 0. Okay, I have taken this. Okay, next one is maximize. Z is equal to (300x1) plus 400x2, subject to linear constraints of 5x1 plus 4x2, 5x1 plus 4x2 is less than or equal to 200, 3x1 plus 5x2, 3x1 plus 5x2 is less than or equal to 150, 5x1 plus 4x2 is greater than or equal to 100, and 8x1 plus 4x2 is greater than or equal to 80, and x1 x2 greater than or equal to 0. Okay, how many problems you have taken? 3, no? 3
Yes,
or
sir.
3, okay. Take one more. Maximize Z is equal to 3x1 plus 2x2, subject to linear constraints of x1 minus x2 greater than or equal to 1, and x1 plus x2 is greater than or equal to 3, and x1 x2 greater than or equal to 0. Okay, so whatever 4 problems I have given you just now, they are all special cases of graphical method of solution, or special cases of LPP. You just try to solve them and solve them in tutorial notebook. जर तुमच्याकडे तसं काय सेपरेट तुम्ही ट्युटोरियल नोटबुक ठेवले असेल तर त्यात सोडवा, नसेल तर तुम्ही काय सेपरेट पेजेस घेतले असतील तर त्यावर सोडवा. Because whatever problems I am giving you for homework or tutorial, you have to scan them and upload them as your assignment whenever I tell you at that time. Is it okay?
Okay, sir.
Okay, sir.
त्यामुळे जर तुम्ही ट्युटोरियल नोटबुक सेपरेट असेल तर तिथे सोडवा. आणि हे सोडून जर कोणाला काय अजून ऍडिशनल प्रॉब्लेम तुम्ही होमवर्क म्हणून किंवा प्रॅक्टिससाठी सोडवणार असाल तर सोडवा. तेही तुम्ही स्कॅन करून अपलोड केले तर काय हरकत नाही. ग्राफ पेपरवरच वरती प्रॉब्लेम लिहायचा आणि खाली ग्राफ पेपरवर सोडवायचा, आणि ग्राफ पेपर स्कॅन केला तरी चालेल, किंवा सेपरेट प्रॉब्लेम लिहायचा ग्राफ पेपरवर सोडवायचा आणि दोन्ही एकत्र क्लब केलं तरी चालेल. असं एकच पीडीएफ तुम्हाला करायची आहे. ठीक आहे. आणि पुढच्या शुक्रवारी मी मॉडेल फॉर्म्युलेशनचा 1 किंवा 2 प्रॉब्लेम देईन ट्युटोरियलच्या वेळेला, ते तुम्हाला इथे सोडवायचे आहेत, ते पण स्कॅन करायचे आणि हे ग्राफिकल मेथड पण स्कॅन करायची. आणि या 2 असाइनमेंट तुम्हाला पुढच्या शुक्रवारी मी जेव्हा सांगेल तेव्हा त्या पद्धतीने मोडेलवर अपलोड करायचे. इज इट ओके? इज इट ओके?
Yes, sir.
ठीक आहे.
Yes, sir.
So on Monday we will start with another method, that is simplex method. ठीक आहे. ओके, आतापर्यंत कोणाला काय डाऊट आहे का? सगळ्यांना समजतंय ना? सोपं आहे, फार काय अवघड नाही. इथून पुढे जरा थोडं कॉम्प्लिकेटेड मॅथमॅटिक्स मध्ये कॉम्प्लिकेटेड कॅल्क्युलेशन्स करावे लागतील. इफ यू प्रेझेंट फॉर अदर लेक्चर्स इट विल बी बेटर.
सर जे प्रॉब्लेम दिले ते स्पेशल केसेस म्हटले तुम्ही, म्हणजे रेग्युलर मेथड सॉल्व्ह होतील ना?
सॉल्व सेमच ग्राफिकल मेथडने रेग्युलर पद्धतीनेच करायचे, पण त्याचं मिनिंग सोल्युशनचं इंटरप्रिटेशन इज डिफरंट.
ओके सर.
ओके, or rather